Hi, how are you? This is Leo Guadalupe from People Analytix Solutions. People Analytix Solutions is a consultancy, but we also want to provide research and content for the people analytics practitioners, HR and business practitioners in general, help to understand a little bit better how we're going to solve business problems and help gain control over the most expensive cost that most employers have, which is labor. This is going to be our first video in our content space, and we're going to cover a quick small topic of sunset threshold. The business question being, how should we plan for people retiring? When should we plan for people retiring from our organization? And so with that business question, we'll dig into the people data. I'll show you how to answer that. We'll take a look at our new tools like Copilot to see if there are better ways to do it. And we'll compare and learn a couple things along the way. So let's get going. So we're going to focus now on this sunsetting piece. We would call it the kind of active employees beyond the sunset threshold divided by a total head count. Okay, well, we just need to know what is the sunset threshold. So let's take a look at this, how we would do something like that. So here we have some data, right? And these are just retirement ages of different instances. We have 192 different instances. We can say retirement ages of retirement events in the past 5 years. If you're curious about how I did this, I just used a random number generator paired with the norm inverse function to be able to get us the ages. I used a standard deviation of 4. So this is just to generate the data. The data we analyze should be matching that somewhat because it is a sample. So if we look at that, the average of our sample is 66.51 years. That is close to our mean. And then we have our observed standard deviation of 3.9 or close to our 4. And so now what we want to do is we want to make a histogram. And how do you make a histogram? Well, it's easy enough. You can just put it in the search bar, histogram, and it will show you a statistic chart, and you can pick histogram, and that's how you make a histogram. Just make sure you have this selected, insert histogram right there. You can also find it here in the middle, and it'll make that chart for you. And then you can also edit the bins this way. If you go to, you select the data and you go on your data series editor. Let's see, where is it again? Here it is. You have to click on the axes options, and then you can go by bin width. So I just want to be 2 years of bin, or if you want it to be maybe just 1 year of bin, so you'll have those years show up as just every year. Like they're getting cut by 15.8, but I think you can we set the minimum? But I think it's just because that's probably the observed minimum. Yeah, this is how you can adjust the bin width here. So let's just keep it at 2. And so I'll delete this chart because once we have the histogram, what we want to find out is what's the sunset threshold. So if we say we want the threshold for 95% of the retirements, when do 95% of retirements happen? So if we say we want our lower limit, we want the probability of 0.05, that's at 5%. And we'll do with our mean, that mean observed mean and our observed standard deviation, we'll plug those in. So it gives us about 60.1 for our lower limit. So now that we have that lower limit, it's 60 years of age. So that kind of makes sense. So 95% of retirements occurred after age 60.1. But that's the interesting piece where it's like, while we know that's as you get older in age, you're going to get closer to retirement, that's expected. What is unexpected is if you retire earlier in age, begins at a certain point in time, then at that point, there should be plans in place to begin that sunsetting, right? Having either somebody start beginning to get retrained or starting to get trained on those same skills, or decide whether those types of roles are going to get automated in the future. So eventually, as when everybody hits a certain age, they should begin their sunset planning. The organization should begin sunset planning to figure out what that role is going to look like in the future. However, if you're below a certain age, there's no need to sunset plan because it is less than a 5% chance that you're going to retire before the age of 60, right? So that's kind of what we want to do. We want to make that split. And you can make the adjustment as well. Let's say you want to be more conservative and say, I want my surprise outliers who I don't have a plan for to be the 2% scenario. So let's do that 2%. It's giving me, it's a 58.5. So then that would just shift our lines here to 58.5, be somewhere here. And then this is what our risk profile will look like. As soon as you enter 58 years of age, you should begin sunset planning. You could go the other way around and saying planning for those scenarios, it can be quite an issue. So we probably want to have some awareness, but not necessarily be too aware because it might cause us to do a lot of overwork, start bringing considerations in too early. So you can dial it back and you can say, let's do 10%. We're okay with 10% tolerance on missing. On 10% of retirements, we're just not going to have, they're going to be unplanned and they're going to catch us off guard. So having said that, then you roll that to 61, right? And you'll put that all the way here. And so you now take on more risk, but you don't have to be as vigilant, whereas you have another year where you can let go unplanned for sunsetting. So let's put it back to where we were at our 95%, which is our 60.10 age. So this is how you would have a sunset policy created. Now let's do something interesting. This is the old way of doing things. How would a new way of doing things look like? So if I introduce Copilot here and I say, here's my data. Let's get a chat going here. Okay. I have 192 observations of retirements. Find the age at which my organization should begin to plan for sunsetting an employee role. And let's see what it does. So it's thinking, it's analyzing, and let's see what it says. To determine which organization should begin planning for sunsetting an employee position, we need to find the age at which 95% of retirements have occurred. So it has the data of 192 observations, and it says the data in your file lists retirement in a column, but it appears the column header may not be the actual retirement age. To proceed, I'll identify the correct columns in retirement age, calculate 95th percentile, the age below which retirements occur. You could confirm that if the retirement ages are in a single column, or if you'd like me to use the listed ages. So let's see, would you like me to use the ages from sunset threshold example to calculate sunset threshold? Yes, the data is in sheet 2, column B, header in row 5, data. Row 5, data begins at row 6. Based on your 192 retirement observations, the age at which your organization should begin to plan for sunsetting an employee position, the sunset threshold is approximately 72.4 years. This is the age at which 95% of retirements have already occurred. So planning for succession, retirement, transition should ideally begin before this age. If you need a breakdown visualization or want to adjust the percentile, let me know. Yes, I need a breakdown and visualization. Let's see what it says. So it's got the median age of 60, the mean age is 6.5. Okay, got something a little different. I'm not sure why that would be. And let me just make sure I grabbed all the data. The median 66.85, 197. Got all the data correct. I'm wondering why my data is not grabbing that. Standard deviation 3.88. It's a little different. I'm not sure why the data is a little different. Okay, median. Let's try the median. Yeah, that looks correct. Okay, this histogram shows a visualization of the distribution of retirement ages for the 95th percentile, with the red dashed line making the 95th percentile. I'm not seeing the red line, dash marking line. The visualization helps you see where most retirements. So the visualization helps you see where most retirement cluster at the point where proactive succession planning should begin. Would you like me to highlight the top 10 oldest retirement ages or create a cumulative distribution chart for deeper insights? So it gave me actually the opposite of what I wanted. Maybe that was my prompt. Or see, I didn't even prompt it to do that. It just told me which 95% of retirements have occurred, right? But they've already occurred. We need to plan for that. But it actually did is it changed this from 5 to 95. And that's how I got 72. So I think the data is processing the data a little different. I'm not sure if it can really spit it back out at me. But here it told me 72.4 years, 72, I'm getting a little bit bigger. So there's some data misalignment. The data doesn't seem correct. Let me ask it to see if my sources, can you give me, let's even add it up. So if I take this data and I say copy code, well, let's look at the code. It's gonna look at, I'm wondering if I can find, I don't know why the data is different. Mean age is 65.5 years. So can you give me an output of all the ages and of the calculation or the mean? Oops, I misspelled age. But let's see if it, memory probably still doesn't know what I'm looking for. Let's see. So we got Copilot analyzing. Total sum, it's got 191. So it's missing an observation. I'm not sure if it's the first one or the last one, was probably. So let's see. Why does it have 191 observations? It might be that, might be a little bit lower. 6655. That's exactly what I had. So it didn't grab the first line. I guess it assumed that the first line was a header. 66, yeah. It assumed the first line when I told it in my prompt in position. Data is in sheet 2, column B, header in row 5. The data begins at row 6. I guess it didn't interpret this. It didn't know that this was a header. So I think that's what it says. So you got to pay attention to those issues where it will just grab, it will miss a row. So it's a good thing that we checked. But so now it all makes sense. We know that it did the wrong thing with respect to sunset threshold, getting the 95th percentile. By that point, it's already too late. 95% of the people have already retired. What you want to do is you want to catch when 50% of the people are going to retire and control for that outlier. Meaning your default is not to trigger the sunset plan. The sunset plan is the default, right? When you hit a certain age, you start sunset planning. What you want to do is you're setting your acceptance for an unplanned retirement. So once you decide, okay, what is my organization willing to tolerate? Then you set that limit as where it is, whether it's 5%, 10%. The higher, the more tolerance you have, the less work you'll have to do because you don't have to plan for as many years. Probably you'll push the age out. But if you want to be more conservative, you want to have a plan for everybody, and then you'll need to set that tolerance a lot lower, like maybe a 1% tolerance. But I think 5% tolerance seems to be a pretty good standard. And even a Copilot tried to use 95 percentile. It just did it the wrong way and used the other tail. So it's a good thing to do it all the old manual way, to understand what you're doing before you go ahead and ask Copilot. It did miss a data point, but we see that it didn't understand things properly and would have given you a really bad answer if you go ahead and present that. If you say, hey, our retirement threshold is going to be 72 years old, when most people have already retired, you probably get laughed out of the room. it's one of those things that you have to pay attention to as we get into this age of AI. And so once again, this has been Leo Guadalupe from People Analytix Solutions, trying to help everyone through this wonky HR landscape